Okay, so this is Algebra 1, Lesson 8.2, Day 1. So I'm splitting the 8.2 notes up into 2 days. So this is the first day of the notes, and we're talking about factoring the greatest common factor out of a polynomial in this first section. So let's start with our warm-up. So we're going to simplify by distributing this 2 to each part of what's in parentheses. So we get 2w plus 2. For this next one, 3x times x squared is 3x the third. Remember, we add the exponents. And then 3x times negative 4 is negative 12x. For the next one, they want us to find the GCF, the greatest common factor. So the biggest number that can be divided into both of them. So what is the biggest number that goes into 4 and 6? Well, it's actually 2. So 2 is the biggest number that can be divided into both of them. And then we have to look at our variable. So h and h squared, remember it's the smaller of the exponent, so there's only one h on this one, and there's two h's here, so the one that goes into it is just the h. On this next one, 13 and 26, the biggest number that goes into both of them is 13. 13 goes into 13 one time, and 13 goes into 26 two times. And then what goes into the most variables, we can only do one p into it. Okay? So we're going to look at factoring polynomials by using the greatest common factor, and then make sure that you are aligning common factors so that it can help you find the greatest common factor when you're writing everything out. Just make sure you line everything up. Recall that for the distributive property, if I have AB plus AC, I can pull out an A and have B plus C in parentheses. The distributive property allows you to factor out the greatest common factor of the terms in the polynomial. So factoring means to write it as the product. So it means to go back to this version, not to the distributed version. So a polynomial is in its factored form when it is written as a product of a polynomial or of a monomial and a polynomial that cannot be factored further. So for example, 2 parentheses 3x minus 4x is not fully factored because there's a common factor inside still that I could pull out. So we're going to look at some examples. So for factoring a polynomial, what you want to do is you want to find the greatest common factor first. So we've got to look at the coefficient. What's the biggest number that can go into it? It's a 2. And then we look at the variable, okay? Are there any variables that go into both? There's not. So 2 is our greatest common factor. So we're going to rewrite this as factors. So 2 times x squared makes up that first one. And then minus 2 times 2 makes up our second. So what is the common thing I can pull out? Well, it's a 2. So I can pull out a 2, and I'm left with the x squared minus the 2. Now we can check our answer to make sure that we can get back to the original one. We would just distribute. So 2 times x squared is 2x squared. 2 times negative 2 is minus 4. So we are back to the original. So that's good. So let's try another one. So we're going to find the greatest common factor. What goes into 8, 4, and 16? The biggest number is 4. And then for the variables, x to the third, x to the second, and x, the biggest one that goes in is an x. So now we're going to write it as a product. So the first 8 times x to the third can be written as 2x squared times 4x. Then I can have minus x times 4x. So I'm basically splitting each term up. And then I can have minus 4 times 4x. So if you look, I can pull out a 4x out of all of them. And I'm left with 2x squared minus x minus 4. Again, you can distribute back to check. So when I check, I get 8x to the third minus 4x squared minus 16x. So this is my factored version. If you see a negative sign out in front, pull out a negative first. So if I pull out a negative, that's going to make all the signs inside the opposite, okay? Then we want to find our greatest common factor of what's inside. So if I look at that, it's going to be a 2 and an x because I have a 2 into both of them and then an x is my smaller. Okay, so now we're going to pull out that negative 1 and write this as 7 times 2x plus 6 times 2x because 7 times 2x gets me back to 14x and 6, it should be 6x there. 6x times 2x gets me back to 12x squared. So now I can pull out that 2x, and I'm going to multiply it by this negative 1. So now it's a negative 2x and I'm going to leave what I have left on the inside. Again, you can go back and check. If you multiply negative 2x by 7, you'll get negative 14x. Negative 2x times 6x is negative 12x squared. So that is correct. So this is our factored version. And I already pulled out the negative, so I'm going to leave that. If you factor out a -1 in the first step, be sure to include it. So if you pull it out, you've got to take it with you through all the steps. You can't just leave it floating out there. Okay, so we're going to factor this one. We're going to see what is our greatest common factor. What number goes into 3, 2, and 10? Well, the biggest number that goes into all of them is just a 1. That's the only thing they have in common. So let's check if our variables have anything in common. We've got an x to the third, x to the second. There's no x's in common with all of them, so my only greatest common factor is 1. Okay, let's do this last example. The area of a court for the game squash is 9x squared plus 6x square meters. Sorry, I was reading squash and I was confused. That must be a game that I don't know. Factor this polynomial to find the possible expressions for the dimensions. So we know that a basketball court, I have a dimension here and a dimension here, and to get the area, it's the two of them multiplied together. So we're going to separate out the greatest common factor. So what I have in common is a 3, and then I have an x in common. So I can rewrite this as 3x times 3x plus 3x times 2. So my greatest common factor is 3x. So now I can rewrite this with the 3x out, and I have left inside a 3x plus a 2. So my products are 3x and then 3x plus 2. So again, let's review. You're pulling out the greatest common factor, and you're seeing what's left, that when you multiply it back, you'll get to the original answer. Because if I multiplied this back, I would still get 9x squared plus 6x, which is the original. So this is my factored form, okay?